by the numerator. I already know that numerator is not equal to 0. So -1 multiplied -3 is +3. So I'm going to write +3 here. +3. 2 times 6 is 12. All over. For this square root, I have -1 squared, that's 1, 2 squared. So here is going to be square root of 5. Square root of 5 multiply. This is 9. 3 times 3 is 9. 6 times 6 is 36. 36 plus 9 is 45. 45. And I hope you know that these are okay. And I can write them in one square. So I have, in the numerator, I have 15 all over. So the angle is not 0. Angle is not 90 degrees because the numerator is not 0. Then the denominator. So I have square root of 5 multiplied square root of 45. So I can pull up my calculator quickly. I'll pull my calculator up. Remember, I'm looking for the angle between these two vectors. So cos theta, angle between two vectors. All right, so I will just get my calculator and throw them in there. All right, so remember that the angle is going to be in degree. The first thing you want to do is make sure that your mode is in degree. I can't say it enough. You don't want to misattach that. Okay, so I am going to store my 15. I'm going to store this 15 in X. Makes my world easier. And then I'm going to maybe say divided by parenthesis square root of 5. Square root of 5. Okay, get out here. All right, so I'm going to say square root of 5, square root of 5 multiply square root of 45, square root of 45. And then I have an answer. And that answer is 15. The numerator is 15. The denominator is 15. Therefore, the cosine theta is equal to 1. Of course, you know, so I'm now going to find cosine, of 1. Okay, you don't even have to use your calculator. See, we know that in a unit circle, we want to find where cosine is. This angle is not 0. So it's not 90. So we come over here. We see cosine is 1 here, 1, 0. We know that this angle we're talking about is, we don't know where it is. Let me not say we know where it is. This one is 0, 1. The first coordinate is 1. This is -1, 0. This is 0, -1. Okay, and so cos inverse of 1 is 0. Therefore, the angle between them, let's just find it out, make sure. So the cos inverse is 0, but I just want to make sure that this is right. So we want to find the cos inverse. Cosine of 0 is 1. So cos inverse of 1 is equal to 0. So the angle between them is 0. Okay, they're not in a straight line though. There might be. Okay, so this is what we got in this. We're going to answer another question on angle between two vectors. Angle between two vectors. So let's go up and check where we see angle between two vectors. Angle between two vectors. So let me go down. We already talked about sine and cosine rules. So now we are working on vectors today. So looking for angle between two vectors. Okay. Find the angle around the, okay. I'm looking for angle between two vectors. All right, number 28 in this practice test. Number 28 in this practice test is asking us about angle between two vectors. So find the angle between two vectors to the nearest tenth of a degree. So you write the formula. Cosine theta, the angle between two vectors, is the dot product of the vectors divided by magnitude of the two vectors multiplied by each other. Dot product of the two vectors multiplied by magnitude of the first one times the magnitude of second one. So let's find the dot product first. So I'm going to multiply them immediately on the numerator. So I have -2 multiplied -1 is +2. Okay, plus 5 multiplied -5, -4 is -20. So I already know that the dot product is not 0. So the angle is not 90 degrees. The dot product is not 0 because the numerator is not 0. So the angle between these two vectors is not 90 degrees. Okay. And now the next thing is for me to find the magnitude of u. The magnitude of u is square root of the x component squared plus the y component squared. This is my modulus, absolute value, times, in other words, my answer must be positive, times the magnitude of v. The magnitude of v is square root -1 squared is 1 plus -4 squared, -4 squared. Okay, and then I will simplify both the numerator and denominator. So the numerator gives me -18. The denominator gives me, I am going to, first of all, find what is in the radical sign. All right. Okay, that's 4. 4 plus 25 is 29. So 29 is here, square root of 29 multiplied by 1 squared, -1 squared is 1. 4 squared is 16 plus 1. 16 plus 1 is 17, square root of 17. And then I can find the angle between these two vectors. Of course, if I graph these two vectors, let me try and graph them. If I graph these two vectors, how did you see that these two vectors are not in the first quadrant? See, find the angle between them. So let's see. By the way, let's make sure that is the one we're doing. All right. So these two vectors are not in the first quadrant, but we're looking for angle between them though. Looking for the angle between them. Anyway, so we have cosine of the quantity on the right hand side. So I can put this all in my calculator immediately. I can say cosine inverse of the quantity. So I'm going to open another parenthesis in the numerator negative 18 close parenthesis in the numerator divided, you know what, I just have to find, let me find negative 18 first, then divided by parenthesis, that's much better. So parenthesis square root of 29, square root of 29, close parenthesis, multiplied by square root of 17. This is multiplication. Multiplied by square root of 17. I need another parenthesis there. I need another parenthesis there. Square root of 17. I will add another parenthesis to avoid getting quit there. All right, so I'm going to parenthesis, and then I'll close another parenthesis, and I'll insert another parenthesis here, because being careful so that I don't get them. Okay, so I'm going to insert, second insert, parenthesis. Okay, that way. So I have, let me see. All right. All right, let me just delete that, see, and then I'm going to delete this one. I'm going to delete this. Okay. All right, so what I'm going to do is second the square root of 29. And I'm going to close that parenthesis, multiply by square root of 17, and I have 17. Okay, and I have enter. What is it not doing? What is the problem? All right, okay, I see what the problem is. Okay, enter. Okay, then I'm going to divide negative 18. So I'm going to store this in my x. So negative 18 divided by the quantity I stored in x, divided by that quantity I just stored. If my answer is more than 1, it cannot be more than 1. Because remember, we know that the range of cosine is from negative 1 to 1. Okay, so now I'm ready to find the cosine inverse. So what is the cosine inverse of that angle? So that angle is not in the first quadrant, it's not in the fourth quadrant. So I'm just going to find second cosine. And I'm going to put the quantity I just calculated, and that angle is 144 degrees. So the angle between the two vectors is obtuse. So I have found the angle between them in degree. Remember, we're looking for them in degree. So the mode must be in degree. 144, let's see, to the nearest tenth. So 144.2 degrees. The angle between them is 144.2 degrees. One more on angle between, and then one more on angle between two vectors. This formula is not in our formula sheet, so you want to make sure you know it before. All right, so this formula is not in our formula sheet. Let's find the angle between number 30. So this is in unit, the vector here is in unit vector form. That's okay, you can still get the vectors out. The vectors in number 30 are in unit vector form. Okay, you can still get your x component and y component. All right, so I just have the x component in the first vector is negative 3 and the y component is -1. And the x component in the second vector is 0. The y component is 1. That's a unit vector. And I'm told to find the angle between these two vectors. Oh no, this is number 30. So we're doing number 30. All right, the same method, you write the formula. Angle between two vectors is cosine theta. I'll call this one u, I'll call this one v. U dot v all over the absolute value of u multiply the absolute value of v. Absolute value is magnitude. That's magnitude. When we get to polar coordinate, we'll call it modulus. Magnitude and modulus are the same. So in unit 4, we shall call it modulus. But magnitude and modulus are going to be the same. Okay, so now we are going to find the dot product and decide whether the angle is 90. If we find a dot product, we decide whether the angle is 90 degrees, because if the dot product is 0, the angle is 90 degrees. So let's find it. All right, so in the numerator, I have -3. Let me just multiply. -3 multiply 0 is 0, plus -1 multiply 1 is -1. When I add them up, the dot product is not 0, it's -1. Then I will find the magnitude of vector u and vector v. So I'm going to do that on the left-hand side. So I will find the magnitude of vector u and vector v. So I have -1 in the numerator. The magnitude of u is square root, absolute value of the square root, -3 squared plus -1 squared multiplied by the magnitude of v. The magnitude of v is square root of 0 squared plus 1 squared. Okay, so now let's simplify. The numerator gave me -1. Right here I have 9 plus 1 is 10, square root of 10, multiplied by square root of 1. Square root of 1 is 1. Okay, then square root of 10. So I'll end up having -1 over square root of 10. The absolute value is still square root of 10. So, and I'm now going to get the cosine inverse of 1 over square root of 10. Because it's negative, that the angle between those two vectors is going to be obtuse. And the angle, the vectors, the angle is not in the first quadrant, it's not in the third quadrant. So cosine theta is that. Now cosine inverse of -1 over square root of 10. So let's find out using our calculator. All right, so we find that using our calculator, and we see that cosine inverse of -1 divided by square root of 10, and then I'm going to close the outer parenthesis, and I want to find the angle. The angle there is 108 degrees. It is obtuse. So the angle between the two vectors is 108 degrees. To how many decimal places? You check the number of decimal places. Round to the nearest tenth. So 108.4 degrees. 108.4 degrees. Okay. Well, the next thing we want to do is find the resultant of resultant vector. And by the way, we have already been finding resultant vector. The most important thing now is that we want to use the parallelogram law. So you already have this in the test. I think I chose parallelogram law instead of bearing. So you will see questions on parallelogram law. You will not see questions on bearing. That way, I chose one because we don't have time to do both of them. But parallelogram law is what is, you will need that. Okay, so let's see questions on the parallelogram law. Okay, let's see where I'm going to find questions on parallelogram law. All right, see. Okay, I think we haven't done this one. Find the magnitude and positive direction. All right, let's make sure, because this is in the test. Find the magnitude and positive direction. Okay, let's make sure we do this. By the way, anytime I'm told to find the magnitude, let me call this one vector u. The magnitude of vector u is the square root of the x component squared plus y component squared. That is the magnitude. Magnitude of x component squared. So if I have 15 squared, I have 225. I can use my calculator though. So let me put it in my calculator that way. So I have square root, and I have 15 squared plus x squared. I'm not sure why it's not connecting. Okay, 15 squared plus h squared. It's negative, but I can do h squared. That's 64. So I can do just 64, and I get an answer. And then 289, I find the square root of that. That's about 13. And that and square root of that answer. When I hit enter, I have 17. Therefore, the magnitude of u is 17. So magnitude of u is 17. And then I'm told to find the direction. Remember, you will be told to find the positive direction. You actually want to draw a unit circle. You actually want to draw the vector. So I'm going to draw the vector. I'm going to draw this vector. So I want to know the quadrant that this vector is. Okay, 15, negative 8 is in the fourth quadrant, somewhere here, fourth quadrant. This is the terminal, is the initial of the vector, and that is 15, negative 8 right here. Okay, and I am told to find the positive direction. I hope you know that angles go in counterclockwise direction. So whenever you finish getting this answer, this is the answer you're getting right here. You are getting an angle, a reference angle that is in the third quadrant. But for now, you are going to be using the reference angle to find what is that. What is it? I'm just going to use theta here. Call this one theta. Okay. And then I can use tangent. What do I know? I know that this is 15. I know that this is negative 8. Tangent is negative in the fourth quadrant. So tan theta is equal to x component, which is, by By the way, we are using y over, let's go to y over x. Y over x. Opposite to theta over adjacent. That, remember SOHCAHTOA. You remember SOHCAHTOA. See, every question you're asked now, they're making sure you know your unit circle. See, we are in vectors, but we're still talking about unit circle. When we get to polar coordinate, we shall be talking about vectors and so on until the class is over. Well, the class is almost over though. Okay, so now tangent of the angle theta is 15. I don't have to use negative 8 because I already know that the angle will be negative. It's in the fourth quadrant. Either way, I can just use the reference angle, but when I finish, I will find 360 minus that reference angle. 360 because the angle in the fourth quadrant. The reference angle in the fourth quadrant is 360 minus theta. Okay, so in other words, I'm going to find tan inverse. So tan inverse of 15 over 8. So let's do that. I'm going to get my calculator. And I'm going to clear. And I find tan inverse of 15 divided by 8. 15 divided by 8, I'm getting the reference angle. When I get this angle, and that angle is 61, the reference angle is 61.92, and you don't want to subtract. So I'm going to store this angle in my x. So the next thing I want to do is 360 degrees, because this is the fourth quadrant. So I'm looking for the angle in the counterclockwise direction. It's a positive angle minus what I stored in my x. And so I have 298 degrees to how many decimal places? How many decimal places? Okay, so I'm told to find positive direction. So it's the angle in counterclockwise direction. And then leave your answer to the nearest tenth, 1 decimal point. So 298.1 degree. 298.1 degree. 298.1 degree. All right. So one more about angle in the positive direction. Find the magnitude and positive direction, 24. Find the magnitude and positive direction of the, look at number 24. All these questions are in the test. In that test, you have about 20 questions out of 35. Oh, I took one out. I took bearing out. So you have 20 questions out of 34. You omit the bearing question. So don't have all the time in the world to. Okay, now I'm actually going to review bearing if we have time, but I don't think you will have time to get into all those. Okay, the last one of angle, last example on angle in positive direction, because we need to have time to do parallelogram law. Find the magnitude and positive direction of the vector. So let's name this vector u. Vector u implies 1, negative square root of 3. All right. So first of all, let me find the magnitude of the vector u. The magnitude is square root of the x component squared plus the y component squared. But if I'm squaring any negative number, the answer is still negative. Therefore, the magnitude of this vector is going to be square root of 1 plus 3. And square root of 4, and it's actually going to be 2. We're not doing negative plus or minus because it's absolute value. So the magnitude of u is 2. The magnitude of u is 2. So we found that. Okay, magnitude of u is 2. Then the positive direction of this angle. So we want to draw. When I'm told to find positive direction, I draw because I actually want to know which quadrant that the angle is. It helps a lot. Makes your work easier if you know the diagram. If you know where the quadrant in which the vector is. Okay, so this vector again is in the fourth quadrant. This vector is in the fourth quadrant. All right. So it's a vector, so you need to have an arrowhead. And the initial point is right here. The terminal point is right here. So I have 1 negative root 3. Okay. But I need to find the value of this angle, the reference angle. For me to find the value of that reference angle, I need the angle theta. It's not given to me. Okay, so the y component is negative square root of 3, but I'm just going to solve by 3. Okay, and the x component is 1 right here. By the way, this is the component form. If you're told to write your answer in component form, this is component form. If you're told to write it in rectangular, in a trigonometric form, then it becomes 1 cos angle. I don't have the angle here. When I finish, I'm going to write. Okay, so now I'm looking for the angle theta. I have the opposite, I have the adjacent, so I can use tangent. Tangent theta is opposite. I'm going to omit the negative here. Root 3 over 1, opposite of the hypotenuse. Okay. Okay, so now I'll find tan inverse of root 3 over 1. And by the way, if I draw a special right triangle, and this is 60 is opposite root 3, and this is 2, and this is 1. So tangent of 60 is root 3 over 1. So actually, the angle is, the reference angle in the fourth quadrant is 60 degrees. So this angle is 60 degrees. And since this angle is 60 degrees, the angle in the right, in counterclockwise direction, the positive angle is 360 minus 60. 360 minus 60 is 300. So the angle in question in positive direction is 300. So the direction angle is 300. So be careful when you're told to find the positive direction. They want to know that you know your unit circle. They want to know that you know your unit circle, positive direction angle, and it's already in the test. We have done 2 of them, so we have tried. So the next thing now we want to do is solve problems on parallelogram law. If we can do 2 of them before the time is over, because that is the application that, we haven't actually done the Heron's formula. Okay, we're going to get to Heron's formula because the Heron's formula is in the test. The Heron's formula is in the test. Half AB sine C is in the test. Parallelogram law is in the test. So I just want to make sure we do 1 of each. That way you can remember that. Okay, so anytime, let's draw a parallelogram. Remember when you were in geometry? When you were in geometry, we want to look at the properties of a parallelogram. A parallelogram is a quadrilateral with opposite sides parallel, equal and parallel. So equal and parallel. And so this, forgive my crooked diagram. Okay, so opposite sides are equal and parallel. equal, and parallel. Well, the diagonals does not bisect the angle. I hope you remember that from, that is, the diagonals of a parallelogram does not bisect the angle. So if this angle is 100, you do not expect this one to be 50, and this is 50, no. Okay, so let's actually use, I need to redraw this. So we want to solve this problem using parallelogram law. And by the way, that's what we are told to use though, parallelogram rule. So I want us to see that the vectors are going in different directions. And that's why it should be. So all I need to do is complete a parallelogram of that vector. Okay, and I'm going to draw a diagonal, even though the diagonals does not bisect each other. I still have to draw a diagonal. But what do I really know? I'm given that this angle is 60 degrees. Adjacent angles of a parallelogram are degrees. So if I know that it's 60, this is 120. If I know this is 60, this is 120. Okay, so, but the angle here is not 30. This is not 30. You don't want to do that. So use the parallelogram law to find the magnitude of the resultant. So this is the resultant. The diagonal is the resultant vector. The diagonal is the resultant vector. So let's see what we have. We have that this force here is 14 pounds. And this force here is 3 pounds. So we have enough information to solve the problem. We do have enough information to solve the problem. This is also 3 pounds. Remember that opposite sides of a parallelogram are equal. So we have two congruent triangles. I'm going to bring one out. Okay, I'm going to bring one of them out. All right, so bring one of the angles out, one of the triangles out. I have this. What do I know? I know that this is 120 degrees. I don't know this angle, but I know that this is 3 pounds and this is 14 pounds. I have enough information to find the resultant vector. The resultant vector is this big line. But which formula do I use? Do I use the cosine rule or sine rule? I want you to watch that I am given one angle and the adjacent sides. Two sides and an included angle. So this is a candidate for cosine rule. Therefore, the resultant force is equal to 3 squared plus 14 squared minus 2 times 3 times 14 cosine of, I didn't give this a name, but it's the cosine of 120. You apply unit circle again. Cosine of 120, by the way, 120 is in the second quadrant. Cosine is negative in the second quadrant. The reference angle in the second quadrant of 120 will be 180 minus 120. 180 minus 120 is 60. So cosine of 60, we already know it is 1/2. So we rewrite cosine of 60 is 1/2. So this is 3 squared plus 14 squared minus 2 times 3 times 14. Cosine of 60 is 1/2. One thing we need to remember is that the sign here is negative. So this sign changes. You got to be careful because that sign is negative. Negative is positive. So these two, I will cancel this. And so let's find the side. The side that is the resultant force. I pull my calculator up, and I can now find the square root, because I'm going to square both sides. So I'm going to clear square root of 3 squared is 9. I can just go put 9 there, plus 14 squared plus 3 times 14, 3 multiply 14. Okay, and that's it. All right, so I have to check and make sure that I got it right. 9 plus 14 squared plus 3 times 14. We have taken care of the 2. And when I hit enter, we found the resultant force. Of course, the resultant force cannot be negative. Round to the nearest tenth. Therefore, the resultant force is 15.7. The resultant force is 15.7. 15.7. So see how we used the parallelogram we learned from geometry and cosine rule and unit circle to solve a problem. One more. Let's do one more problem on parallelogram law. One more problem on parallelogram law. It's already in the test. I think number 21 is about parallelogram law. So let's do number 21. The two vectors are on opposite direction. I have to draw a diagonal from the middle of them. Complete. So complete the parallelogram. And let's say crooked parallelogram. Crooked one. All right. All right. So complete the parallelogram. Okay, much better. And then the opposites, see the force. Here is 6. The force here is 11. They're in pounds. Opposite sides are congruent, of a parallelogram are congruent. The diagonal has got to go between the two forces, the two vectors. So the diagonal is the resultant force that I'm looking for. That is the resultant force. Okay. And this is R. The diagonals of a parallelogram does not bisect each other. But one thing I do know is that adjacent angles of a parallelogram are congruent. So 180 minus 114, 180 minus 114. So I have 180, take away 114. And I have 66 degrees. So the angle here is 66 degrees. 66 degrees. And the angle here is also 66 degrees. Opposite angles are congruent. Opposite angles are congruent. The diagonals does not bisect the angle. Okay, now that I have drawn a diagonal, I can just bring one triangle out. Bring one triangle out. And then this angle is 66 degrees. This is 11. This is 6 here, and this is 11 here. Okay, and this is the resultant force. And again, I cannot use sine rule here because I'm given two sides and an included angle. This is a candidate for cosine rule again. So R squared, the resultant force, is equal to 6 squared plus 11 squared minus 2 times 6 times 11 cosine of 66. And then I can pull them into my calculator like that. So I just get my calculator clear. And then I want to find the square root of the quantity in the right-hand side. So I do second square root. And then I put that 6 squared plus 11 squared minus 2 times 6 times 11 cosine multiply cosine of 66 multiply by cosine of 66 close parenthesis. When I hit enter, I have 10.16. Therefore, the resultant force is 10.16. To how many decimal? Nearest 10, 10.2. 10.2 pounds is the resultant force. Okay, 10.2 pounds is the resultant force. All right, so we have done 2 parallelogram laws. The next thing we want to do is Heron's formula. So find the area of a triangle by Heron's formula. So let's find a question on Heron's formula here. And at the end of that, we are ready for the test. Our test number 3 will open, test and quiz will open in the morning and close by midnight. Unit 4 test will open next Friday and close by midnight. When the Unit 4 closes, I will put in the final exam. Because after Unit 4, by the way, Unit 4 has 5 sections, 11.4 to 11.6, 8.1 to 8.2. So we are gone more than half. We're almost done. So the next thing we want to do now is Heron's formula. The Heron's formula. I hope it's in this and this. I hope it's in this, but it's already in the test though. So Heron's formula is in the test. If it's not here, I'll find it somewhere else. All right, so we are looking for find the area of a triangle using the Heron's formula. And by the way, you may not be told what to use. The question can say, use the appropriate formula. So nobody tells you, no one tells you to use the Heron's formula. It is your responsibility to know that it's Heron's formula. Nobody tells you. So let's go. I'm going to use Heron's formula. We know it from a geometry class, Heron's formula. So they won't tell you which formula to use. You have to figure out which one. So area of a triangle. By the way, let me just sketch a triangle. I'm going to sketch that triangle. A, B, C, where the side opposite A is small, side opposite to B is small b, small c, small b. And small a is 15 meters. Small b is 10. Small c is 13. Okay, so we are ready to find. Okay, so there's something called S, and S is called semi-perimeter. S equal to semi-perimeter, which is half of perimeter. And perimeter is the sum of all the sides. Semi-perimeter. All right, so, and semi-perimeter will be 15 plus 10 plus 13 divided by 2, semi, which means you're going to divide it by 2. 15 plus 10 is 25. 25 plus 13 is 38. 38 divided by 2 is 19. So semi-perimeter is 19. That is 25 plus 13 is 38, divided by 2 is 19. So our semi-perimeter S is 19. Now we write the Heron's formula. So by Heron's formula, area equal to square root of semi-perimeter into semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, and then simplify. So we're going to just put it in. So our A is equal to 19 into 19 minus, let's see the numbers, 19 minus 15, 10, 13, minus 15, 19 minus 10, 19 minus 13, and I'll pull up my calculator. I can put all of them in or just finish simplifying them. So the area by Heron's formula is going to be 19 multiplied. 19 minus 15 is 4. 19 minus 10 is 9. 19 minus 13 is 6. And then I'm going to put this in my calculator. All right, so I'm going to clear second square root. All right, 19 multiply 4 multiplied by 9 multiplied by 6. And then I hit enter. So this is the area of the triangle. Let me see, in square unit, by the way. So let's not forget that is square unit. So we go to square meters. So the area is 64 square meters. I don't know, just let's check and see. So if you're told to use 1 decimal point, then it's 64.1 square meters. So the area in that, this is just a reminder of your geometry, so you can do this. And so we're actually going to stop here because that's all I have. We have done sine and cosine rule. Let me see. We did sine and cosine rule. So we can actually answer any other question here. Can actually answer any other question. Okay, so the applications we're going to